Okay, you should have explained, but the first one, yes, they are similar. And the second one, no, they are not. Talk about it with the people next to you. We'll discuss it in a moment. Go.
These two angles are congruent to each other.
There are. I see the 90s. Those match up. But how do you know that there's two sets?
Because you add the two angles that you get in the one triangle and subtracting by 180 and do the same thing for the other triangle.
Very good. Guys, you had to find the missing angle. So once we found that both of these are 39, those are congruent. Therefore, I can say that these are congruent by what theorem, guys? The AA similarity theorem. So you could put yes, the AA similarity theorem applies because there's two sets of congruent angles. All of the angles are congruent, therefore these two triangles are similar. Guys, I needed some sort of explanation, and you had to talk about the angles. If you referenced the sides, you would not have gotten this one right because we don't know anything about the sides, okay? And then you still have to write a similarity statement. And what I was looking for there is that the order of the letters was correct. Who wrote the similarity statement? Andrew?
Triangle ACE is similar to MNL.
MNL. That is correct, okay? Because M is corresponding with A, N is corresponding with C, and L is corresponding with B. Remember, the order is very important. Guys, if you didn't put all three of these, they were each worth 5 points, you lost 5 points on your quiz. Just because you didn't read the entire instructions, okay? All right, number 2. Yeah.
Quick question. If it's no, you don't have to make a similarity statement, right?
If it's no, you should not have written a similarity statement, correct? But you still needed to explain. It wanted you to explain regardless, okay? So for number 2, they're not similar because when you find the third angle, I believe this one is 66 degrees. Can you guys check me on that?
Yeah.
And this one was 95 degrees. So how many congruent angles do we have between the two triangles? Only one. So you had to write no, but you still had to explain it. Why are these two not similar? Very good. You can either say two things. You can say there's only one set of congruent angles, so not all the angles are congruent, or the angle-angle theorem does not apply. So no, not all angles are congruent. And no similarity statement for this one because the two triangles are not similar. So it was impossible to write a similarity statement. Lesson, guys, is we've only learned basically one theorem for proving triangles of congruence. It's the AA theorem, right? We're learning two more today, and it's called the SSS theorem and the SAS theorem. Now, these seem familiar, right? Because we use them for congruence. Do you guys remember those two theorems?
Yeah.
But these are no longer congruence theorems. In these, we're proving what? Similarity, okay? So they're going to be a little bit different. So let's go ahead and take a look at the formal definition of the side-side-side similarity theorem. The side-side-side similarity theorem says if the corresponding side lengths of two triangles are proportional, then the triangles are similar. But you have to prove it not just for one, not just for two, but all three of the sides have to be proportional by your scale factor, okay? So let's just hypothetically say we were asked to prove that these two triangles are similar, okay? As always, I want you to start by writing your numerator and your denominator. So that way you're consistent throughout the problem, okay? And then go ahead and match up corresponding sides. So we would take AC and put it over, what's the corresponding side to AC? DF. Now, hypothetically, that should be equivalent to AB. What's the corresponding side to AB? DE, very good. And the last two sides? CB over FE, very good. So guys, this has to hold true in order for these two triangles to be similar. Now, some of you might be asking, how did he know like which ones to match up? Because you're not going to be given this similarity statement, right? 10 is the largest side in the larger triangle. Do you guys agree?
Yes.
Should that match up with the largest side of the smaller triangle? So I want you to put largest to largest. And then do you agree that if 6 is the smallest side, it should match up with what? The smallest side over here, okay? So always use that logic, because there's no way that you're going to have two similar figures if the largest sides are not going to match up. And same if the smallest sides don't match up, okay? So now all we do is we substitute the values into this expression and we see if it holds true. If it does, then we've just proved side, side, side congruent, or not congruent, similarity. So let's check it out. What was the value of AC? What am I going to substitute in there? 10. What about DF? 5. That should be equal to, what's AB? 8 over, what's DE? 4. And it should be equal to 6 over 3. Now remember, all of these are going to be the same, hopefully, and they'll all be our scale factor. So what's 10 divided by 5? What's 8 divided by 4? And what's 6 divided by 3? So, does it hold true? Sure. So these two triangles are similar by the side, side, side. Similarity theorem. Now you have to be very careful here because there was a side, side, side congruence theorem. So make sure you're writing that similarity theorem down. Angle, angle was different because you can't prove that there's two congruent triangles with two angles of congruence, right? You needed to know something about their sides. So angle, angle, you could just write angle, angle theorem. For this one, you have to put similarity because there is a side, side, side congruence theorem, okay? All right, any questions on this one? Okay, next theorem that we're going to learn about is side, angle, side similarity theorem. If an angle of one triangle is congruent to an angle of a second triangle, then the lengths of the sides, including these angles, are proportional. Then the triangles are similar. Please underline the word or highlight the word including. That angle must be an included angle. And if you forgot what that means, it just means it must be like sandwiched in between the two proportional sides. So if you want to draw another diagram of something where it's not side, angle, side, we're going to write not SAS. It would look like two triangles, right? Maybe one's a little bit smaller, where your angle of congruence is over here, and maybe you had 10 and 8, and 5 and 4 over here. Do you see how the sides of proportionality are not surrounding the angle of congruence? It needs to literally, as you're going along in the figure, you should see side and angle in between them and the side. This is a no-no, okay? You cannot apply side, angle, side similarity to this figure, okay? Now, in the one that they gave us, we sure can, okay? We can put a check mark. And then again, you want to match it up by the larger sides going on top of each other and the smaller sides going on top of each other, okay? So, let's make the one on the left, let's make it our numerator. The one on the right, let's make it our denominator. We have the angle of congruence in the middle. And all we need to do is match up the sides, make sure that they're proportional. So AC is going to go over what? DF, and that should be equal to AB over DE. Now, you don't need three sides because what's that second letter in our theorem? Angle, right? We're given the fact that there's a congruent pair of angles, okay? So you don't need that third side. So your proportion is just going to be two pieces, okay? AC over DF and AB over DE. Now, when we plug it in, we're going to get 10 over 5, and that's going to be equal to 8 over 4, which is just 2 equals 2. So we say that they're proportional. We can apply side angle side congruent, or not congruence, similarity theorem. Okay, any questions on this second theorem? Guys, that's the whole lesson, okay? Now we're just going to go do a few examples where we're applying it, but there's really only 2 extra theorems. Please don't forget the first one that we learned. What was the first one that we learned? Angle, angle, okay? So there's a nice little chart on the next slide that compares all 3 of them. There's the angle, angle similarity. I guess technically it's postulate. I'm okay if you write theorem, okay? The side, side, side similarity theorem and the side angle, side similarity theorem, okay? All right, moving on. Example 1. The measures of the sides of A, B, C are 4, 5, and 7. The measures of the sides of X, Y, Z are 16, 20, and 28. Are the triangles similar? I hate it when they don't give me what? A picture. So what am I going to do if I'm taking this test? I'm going to draw one, okay? So I'm going to draw a nice little triangle of ABC. It doesn't have to look like mine. And I'm going to label the sides 4, 5, and 6. It didn't say what order. No, not 6. What was the last one? 7. And then I'm going to draw another triangle, and it's going to be X, Y, and Z. And its sides are going to be 16, 20, and 28. What's that? Now, guys, remember, always start where you're matching up the sides based on their length. What's the smallest or what's the largest side in the black triangle? CB, 7, right? What's the longest side in the red one? ZY. So do you guys agree those two should be proportional? Okay, so if we set up our proportion, we're going to say, okay, CB over, let's make this my numerator, this my denominator. CB over ZY should be equal to, remember, we know nothing about the angle, so our only option here is side, side, side. So let's set up all 3 proportions. What's the second one? AB over XY. Very good. That's the 5 and the 20. Those are both the middle-sized sides. Do you guys see that? Because 5 is in between 4 and 7, and 20 is in between 16 and 28. Are we good with that? And then what do we match up as the last 2? AC over XZ. Very good. Now, could you do it the opposite? Could you write it with the other triangle as the numerator? Absolutely, okay? Just be consistent with it, okay? Now, double check, is AC the smallest side of the black one? Yeah, and is XZ the smallest side of the red one? Perfect, so I'm good. Now I just plug in and I make sure that my ratio holds. So CB is what? It was 7 over 28 should be equal to AB, which is 5 over what was XY, 20. And then we say that this is equal to, what is it, 4 over 16? Okay, now it's just a matter of simplifying, right? What's the common factor between 7 and 28? 7, right? So divide them by 7, you should get 1 over 4, correct? Between 5 and 20, what's the common factor? 5, divide by it, and you get 1 over 4. And the last one? Divide by 4, and you get 1 over 4. Can I prove side, side, side similarity? Excellent. So we're going to use side, side, side similarity theorem. And it applies. Yeah, go ahead.
Instead of 1 over 4, can I just have it as like 4?
Yeah, if you just wrote 4 equals 4 equals 4, that's also true. Because remember, your scale factor is 1/4 or 4, depending on how you look at this triangle, or these 2 triangles. Are we good here? Any questions? All right, this second one, okay? So it says triangle ABC is AB is 2, AC is 5, BC is 6. And then in XYZ, XY is 2.5, YZ is 2, and XZ is 3. Are these two triangles similar? Now, it gave us an extra piece of information here. Do you see how it gave us the similarity statement? So we are no longer able to just be like large side to large side, small side to small side. You have to follow this statement because it wants to know, are all of these parts corresponding? So let's set up our diagram. We're going to draw a triangle ABC, where AB is 2, AC is what, 5? And BC is 6. And then you're going to draw a little smaller one, X, Y, and Z. And we're going to have XY is 2.5, YZ is 2, and XZ is 3. Now, guys, just by looking at this, is it possible for these to be similar? No. Because what's the largest side in the red triangle? In the red one? 3, right? So that 3 is XZ. Shouldn't that be corresponding with AC over here in the blue one? But where's the largest side in the blue one? The 6. Now, to prove this, right, you're going to set up your same proportion with all the corresponding sides, and you're going to find that that proportion is not going to hold true. It's not going to be true. It's not going to be equal. So let's set it up. We're going to take AC. AC should be proportional to XZ. It should be equal to AB over XY. And then our last one is CB over ZY. Then just plug in. So AC is 5. XZ is 3. So 5 over 3 should be equal to 2 over 2.5, which should be equal to CB, which is 6. Whoops. What's happening? 6 over, and then ZY is 2. Are these ratios the same? No, absolutely not. So we're just going to put an X, side, 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 similarity. Shows these triangles are not congruent or similar. Are not similar. Blair, you good? Okay. I know. Yes. Yeah. Cross out example 2. Do not do example 2. I wanted to take it out. I think I put a note in the canvas. If you want to delete this slide, it's fine. Okay. All right. So example 3, we're going to stop after example 3 because the exit ticket didn't work so hot with my last class. When you try to rotate like things that you draw, it changes the size of it. So whatever. You don't need to know that. Example 3 uses all 3 of the theorems that we've had before. Okay. But we're just going to see the difference in applying them. So we have to name the similar triangles postulate or theorem that justifies each of these answers. So let's take a look at A. We've got 2 triangles that should hypothetically be similar. By what theorem, though? Angle, angle. Very good. So, angle, angle, similarity theorem. Go ahead, Alexa. Okay. Angle, angle, similarity theorem. Now, where are there 2 sets of congruent angles? I see one. I see that ADE is congruent to ABC. So angle AB or ADE is congruent to angle ABC. Where's the second? Caden?
The shared angle at the top.
Very good. Angle A, you guys agree is congruent to itself? Angle A. So we have 2 sets of congruent angles. So now, don't forget, it said name the triangles that are similar. How can I name the two triangles that are similar? What are their names? Using 3 letters. ABC is similar to which triangle? ADE is correct. Very good. Now remember, you're going to have to remember which theorem. I know a lot of you can just eyeball it and be like, okay, they're going to be similar. But you have to remember what theorem you used, okay? All right. In letter B, we've got 2 triangles, and we need to compare them. But we're not given any information about a third side. What can we do here? What theorem? Pedro says side angle side. But why? They are sharing an angle. What angle are they sharing? Very good. Okay. They share angle C. Angle C should be congruent to angle C by the reflexive property. Okay? It's congruent to itself. Most angles are. Okay, so now we have to set up a proportion with 2 scale factors, and they should be equivalent. Do you guys agree? That'll prove side angle side. So which triangle do you want to make your numerator? The top one, the small one. Okay, that makes the larger one your denominator, correct? So the denominator is the entire thing. What's the ratio of the sides? Javansky? 6/9. So CD over CA. Guys, what did Javansky do that was very important? He added them together. Don't forget, do not put 6/3 and 10/5. Okay? That is a big mistake at this point. Okay? It's still going to work, okay? But don't do that, okay? So it's CD over CA equals CE over CB. Then we just plug in and we make sure that the ratio is fine. CD is 6, CA is 9, CE is 10. What's CB? 15. Very good. Simplify your fractions. What do you get? 2/3 equals, and then on the other side, 2/3. So side angle side can be applied. Are we okay? Yes? Okay. All right, now for the last triangle, what do you think we're going to use? Side, 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 okay? Now, you can either use process of elimination. You're like, oh, we already used angle, angle. We already used side, angle, side. But also, like, were we given any information about any of the angles in the last example? No. Like, all we know is the sides, okay? So we're going to use side, side, side similarity theorem, which means we have to set up 3 proportions, and they should all be equivalent. Now, be careful here. It didn't give you a similarity statement, correct? Oh, shoot. Hold on. I need to write my my similarity statement over here. What is it? It's CDE is similar to what? CAB. Make sure your letters match up. Sorry about that, guys. Make sure you put that down. That's very important over here. Okay. So we're going to use side, side, side for that last one. You have to go based on the size of your sides. So look at the small triangle on top. Start with either the largest or the smallest one. What's the smallest side on the top? 3, or LK, right? So we're going to make this our numerator. This one will be our denominator. So we're going to put LK over... What is the smallest side for the triangle on the bottom? KO. Very good. Okay, then go to the medium-sized side. What's the middle-sized side in the top one? LM. Because it's 5, right? 5 is between 3 and 6, correct? And the medium-sized side in the bottom triangle, it's ON. Guys, KN is not 6. How long is KN? It's 12. It's 6 and 6 added together. Remember, those are two separate segments. This entire length is 12, okay? Does that make more sense now? I heard some people go, ah. Okay. All right, so now the largest side is clearly what? KM and?
KM and KM.
And KN. Okay? So now all we do is plug in. So LK was 3, KO was 6, LM is 5, ON is 10, KM is 6, and KN is 12. They're all going to give me the same ratio, which is 1/2 equals 1/2 equals 1/2. Boom. You could have also, if you made the larger triangle your numerator, your ratio would be what? 2/1 or just 2. Very good. I know, guys, it's been a long day. Okay, we are done. Once you're done copying down this example, go ahead and turn these in.
Did Sophia Barbosa or Natalie Hernandez show up?
Yes, they were in guidance. Thank you. Thank you, Javonsky. I have to write my similarity statement. So, label the first triangle. LKM, correct? Remember, the first one doesn't really matter the order. Now you have to match it up. What's the appropriate letter to L? O. Start with O, then go to what?
N, K.
It would be OK, and then N. Yes, Tyler. Yeah, you can take a photo. I'll zoom out so you can take a photo of the whole thing.